Here we have a SAT math question. Okay, let's go the information. A cargo helicopter delivers only 100-pound packages on 120-pound packages. For each delivery trip, the helicopter must carry at least 10 packages and the total weight of the packages can be at most 1,100 pounds. What is the maximum number of 120-pound packages that the helicopter can carry a trip? Okay, now let me assume X represents the number of 100-pound packages. Let me write over here 100-pound packages, and Y represents the number of 120-pound packages. Okay, when I add X and Y, I get the total number of packages a helicopter can carry. So according to the information, the total number of packages has to be at least 10. So let's go the information here. For each derivative, the helicopter must carry at least 10 packages. So the X positive Y, this expression represents the total number of packages. It has to be at least 10. At least 10 means it can be equal to 10 or it has to be greater than 10. So greater than or equal to 10. So now I got an inequality from the first information. Okay, now let's go the second information. The total weight of the packages can be at most 1,100 pounds. So the total weight of all the packages can be equal to 1,100 or it has to be less than 1,100. Okay, the weight of one unit of 100-pound package is 100. Then what is the total weight of X number of 100-pound packages? For that, we have to multiply the weight of one package by the number of 100-pound packages. That is 100x. So this 100x gives the weight of X number of 100-pound packages. Okay, now let's find the weight of Y number of 120-pound packages. For that, we have to multiply the weight of one package by the number of packages Y. Then I'm getting 120Y. This is the weight of X number of 100-pound packages, and this is the weight of Y number of 120-pound packages. When I add them, I'm getting the total weight. So according to the second information, the total weight of the packages can be at most. At most means it can be equal to 1,100 or it has to be less than 1,100. So we can use the inequalities in less than or equal to. So now I have a system of two inequalities. In this system, our aim is to find the value of Y, so which represents the number of 120-pound packages, because according to the question, we have to find the maximum number of 120-pound packages. So that is, in this system of inequality, we have to find the maximum value of Y, which represents the number of 120-pound packages. Since it's a digital SAT, we can solve this system for the maximum value of Y using Desmos graphing calculator. Okay, now let's go to Desmos graphing calculator. Here we have Desmos graphing calculator. Now I have to sketch the graph of the system of two linear inequalities over here. Okay, let me sketch the graph of the first inequality, that is X positive Y greater than or equal to 10. So now I have to give this inequality as input, that is X positive Y. So to get greater than or equal to in Desmos graphing calculator, first we have to press Desmos sign and then press equal sign. Then it will become greater than or equal to 10. Okay, now I just graphed the first inequality, that is X positive greater than or equal to 10. So this is the solution region for the first inequality. Okay, now let me give the second inequality as input over here. So just simply press type, it will go to the second line, 100x positive 120y. So press less than sign and then equal sign, it will become less than or equal to 1100. So the green color region is the solution for the second inequality. So like the region over here is a common region for both the inequalities in the given system. So usually, so whenever we have two linear inequalities and we graph them, so the maximum or minimum value of any variable X or Y usually will appear at the point of intersection. So actually in this system, we have to find the maximum value of Y. So the maximum value of the variable Y will appear at the point of intersection. So just find the point of intersection of the two lines over here. So clearly it's 5, 5. So in at the point of intersection, what is the Y coordinate over here? It's 5. So that's the maximum value of Y. So Y can be equal to 5 or less than 5. So Y definitely cannot be greater than 5, because if I go more than 5, for example, if I go to value 6 of Y, so we don't find the common solution for this system, because we find the solution of only the first inequality. So the maximum value of Y in the given scenario is 5. I mean the maximum number of 100-pound packages is 5.